So we're basically continuing what we did yesterday in graphing piecewise functions. These functions are going to look a little bit different, but they're still piecewise functions. We talked briefly about them yesterday. At the top you'll see it says graphing a step function. It's called a step function because it's literally going to look like steps when we graph it. That's because they will all be kind of just segments of horizontal lines. So, first thing I want you to do, same thing we did yesterday, assign a color to each of our pieces here. Just so we can kind of shade where each piece belongs in our coordinating. Okay. So we're shading each piece here a different color. So let's start with this first line that I have in red here. So really, if I rewrite this here, I'm going to graph the line y equals 1 from 0 to 2. So let's just shade where that is going to be placed on my graph. So here's where x is 0, remember? The x-axis is really just a big number line. So here's when x is 0, here's when x is 2. Okay, there's my first section. My next section, that's the line y equals 2. And that's going to be drawn in from where x is 2 up until x is 4. So here's 2, here's 4. Let's just color code our graph so we know where our segments will be. Same thing for the next line. Next one is, zoom out a little bit, y equals 3. F of x equals 3, and we're going to have that function from 4 until 6. So here's 4, here's 6. And our last line, which is actually right in pen here, y is 4. It's going to be from 6 until 8. Color in yellow. Okay. So those colors are just representing kind of where those pieces of the function will be. Okay. All of these are y equals some number, some constant term. There's no x variable involved. So these are all what I call hoys, which means there's going to be a horizontal line, has 0 slope, and it's going to be going through the y-axis wherever y equals that number that's given. So y equals 1, that's in the red section from 0 to 2. So there's no need to make a table for our step functions because they'll always just be horizontal lines. They're going to end up kind of looking like dumbbells. So when I draw this in, first of all, we have to still pay attention to open and close circles. So here I have x is greater than or equal to 0, so that's a closed circle, whereas this is just x is less than 2, that's an open circle. Okay, so y equals 1, here's where y equals 1, I'll have a closed circle at 0, an open circle at 2, and it's a horizontal line. See how that kind of looks like a dumbbell? Okay, there's my graph. Kind of looks like a dumbbell right there. Okay, from 0 to 2. Closed circle at 0, open circle at 2. Our next line is y equals 2, so that's right here, y equals 2 right here. Closed circle, open circle. So why a closed and open circle? So let's go back, look at our domain restriction here. This is going to be a closed circle. This will be an open circle, and that's consistent all the way down through, so my next line again, closed, open, okay, so the line y equals 3, that's going to be right here, again, closed circle, open, y equals 4, closed circle, open circle. there's my final graph. Again, they kind of look like little dumbbells that you would lift at the gym, something like that. All horizontal lines wherever y equals that value, closed and open circles still apply. Okay, so step function's always going to be the same. Y equals some number, horizontal line segments. So I want you to go ahead and try the next two on your own and then watch the second part of the video for step functions.